Good day, grade 9s. This is again Sarah van Grenen, aka Mr. VG, and welcome back to video 2. In video 1, about geometry, we covered the purple part, angles, lines, parallel lines, those three things. And I promised you in this video, we are specifically going to look at triangles, but not just revising grade 8 and 9, or grade 8 I mean, but specifically looking at what did we do this year with triangles, because grade 9 was a big year with triangles. Then in our last video, we are going to specifically look at quadrilaterals, extending it past where we were in grade 8 with quadrilaterals. So when we talk about triangles, it's important that you still again remember all of the lines and angles theorems. If you didn't watch the previous video, hit the pause button, go back to that video, check it out. There's some pearls of wisdom in there. But for this video, we are going to look at triangles. Again, I'm going to divide my triangles into 3 parts for this video. For this video, our first part is going to be all about the basics of triangles. So when we talk about the basics of triangles, it's those theorems like the first one which says that x plus y plus z must be 180 degrees. Now it's not really a theorem as much as it is what we call an axiom, which says it is something we assume. It's a statement we assume, but we've never really proven it. There was nowhere where you actually prove that it's 180 degrees. Interesting, right? What would be our reason we give to the examiner? Interior angles of a triangle. Now, none of this is new. It all goes back to last year already. Then, if I've got that AB is equal to AC, I've got an isosceles triangle. Now, I'm not going to spend time on this slide with it, but in the next slide, I'm going to take isosceles triangles and tear them apart a little bit. So please don't tune out after this slide. There's still a bit more coming, because isosceles triangles are super important for grade 9, but especially for grade 10, 11, and 12. When we look specifically at our last grade 8 theorem, which said that x plus y must be equal to z, and that is because it's an exterior angle of a triangle. Let's move on now away from grade 8 geometry and go to grade 9 geometry. Now, when we talk about this, there's 2 important concepts that came into being in grade 9. It's the first time you really got working with congruency and similarity. Now, when talking about congruency, we are going to go into detail in one of the videos following this one, where we're going to practice it. But there are 4 basic ways of proving congruency in triangles. The first one is when I've got 3 pairs of sides that are equal, and we say side, side, side. Then, if I've got a 90 degrees, that means a right angle, a pair of hypotenuses that are equal, and another side that's equal, that's RHS. Then we have 2 pairs of sides with an included angle. I just want to quickly go back to this before we go over to the next one. This is a very important thing, and I want to just encourage you to understand that it has to be 2 legs and the angle in between the legs. So it's like putting your palms, your wrists together and clapping your hands. That's how I want you to think of this. It cannot be an angle outside of that between the legs. Our last way of proving congruency in triangles is by having 2 pairs of corresponding angles and a pair of corresponding sides equal. So congruency means, and we'll get into that in our video on specifically congruency, two triangles that are exactly the same size and shape, but it doesn't actually just relate to triangles. But let's move on before I get too sidetracked. The last new thing you got taught in grade 9 triangles was specifically looking at similarity. Now, similarity is a very important little thing, and it means that two triangles kind of look the same, but they're not necessarily the same size. How do I prove similarity? By getting the pairs of corresponding angles equal. So angle A and D, B and E, C and F. And if that is equal, then the triangles are similar. And because we're working with similarity, we also have ratios that exist. But if you're getting a little bit confused about what is written on the screen now, relax, we'll get there in the video about similarity. But as I said earlier, I want to just talk a minute or two about isosceles triangles. Now, isosceles triangles basically can be split into two things. Number one, what if I want to prove the angles are equal? So in other words, I'm giving you a triangle with two sides being equal. What do I know? That if the sides are equal, then the angles opposite them are also equal. And our reason would be that it is angles opposite equal sides. If you're in a public school, oh man, they are strict on these reasons. IEB schools can be more lenient, but please speak to your teacher. Your teacher will tell you what is the acceptable reason to use. If I look at the flip side of this, which is proving the sides equal, now I give you that angle X is equal to angle Y. And if that happens, then side AB is equal to AC. Now this is a very, very important theorem, this one, because it's one of the only ways we'll ever have of proving a pair of sides equal to one another, is by literally comparing the angles opposite them. Ladies and gents, please tune into our next video where we're going to dive even further into geometry by specifically looking at quadrilaterals. So this is Isosceles van Grinnen, aka Mr. VG, signing out. Have a beautiful, amazing rest of your day. Cheers.